All right, so for recording purposes, we're starting distance, speed, and time. Please take down the topic, turn to a fresh page, and write down distance, speed, and time. All right, so let's get straight into the story, right? You all can give it a read, and by then, the story revolves around someone called Jibby, right? So you all can give it a read here. Right, so there's Jibby there. Right? So life isn't going too good for him, right? So yeah, Jimmy looks a little different because I use AI to create him. So Jimmy has a very bad backstory. Things wasn't going too good for him in life, right? But I guarantee you, things will turn around drastically for Jimmy eventually. All right, so let's get started with our first piece of calculations, right? So for those who now joined us, we're doing something called distance, speed, time graphs, okay? How much of your, right throughout class, we're going to be having to calculate something called gradient. How much of you all have never calculated the gradient of a line as yet? In case, don't let the word gradient get to you. Gradient just means how steep a line is. Like for example, when you run up a hill, or if you climb a mountain, and some mountains steeper than other mountains, some hills are harder to climb up because it's steeper than another mountain. Now, the technical word for steepness in maths is gradient. So don't let the word gradient get to you. Gradient just means steepness. Now, a very long time ago, right? A very, very long time ago, someone came up with a formula on how to calculate gradient, like to calculate the steepness of a slope. So here's what I want everyone to do. I want you to take down this note. I want you to take down the formula, and then I want you to draw this diagram for me. You notice this is a straight line connected by 2 points. The 2 points are A and B. And for those who think you know how to calculate the gradient of a straight line, feel free, right? Feel free to jump in, work it out without my assistance, and send the answer on the chat. That's fine. Right? So whenever you're trying to find the gradient of a line, remember, you need 2 points on a line to find the gradient, okay? Now, I have 2 points here, A and B. Now, it doesn't matter which point we choose first. You could choose A first or you could choose B first. It really, really doesn't matter. But we all know A comes before B, so, naturally we will choose A first. So A has an x coordinate and a y coordinate. As you all remember, the x comes before the y. So because we decided to choose A first, it will have the subscript x1 and y1. B will also have an x coordinate and a y coordinate. So the first one is always x and the second one is always y. Because we chose A first, everybody had the subscript 1. By default, we would be choosing B second. So you call the second point x2 and y2. And all you have to do is throw it into the formula, right? So how do you calculate? By the way, the symbol for gradient in maths, most of the times they use the letter M, not G. I don't know who decided to use the letter M to represent the word gradient, but some genius decided. So to calculate gradient, the formula is what? Y2 minus y1 divided by x2 minus x1. So let's throw it into the formula. You notice you have y2 and y1 here. So the formula says take y2 and minus y1. 25 minus 8, and then we divide it by what? X2 minus x1. x2 is 20, x1 is 10. So it's 20 minus 10. 25 minus 8 is 17. 20 minus 10 is what? 10. So how much we're going to get? Now, it's up to you if you want to put it as a decimal or a fraction. Remember, I'm not going to fight about that in class. You could put it as a decimal or a fraction. So 17 divided by 10 is real easy to do. So you're going to get 1.7, right? So the gradient of that line is 1.7, as simple. Right? So here's your second example. Let me put in some values for you guys here, right? The points don't have to be A and B. It could be any two letters. Let's just call here 13 and let's see, 13 and 20. And over here, right? Q, I will call it, that's our, 1 second, 22 and 7. Try to find the gradient of that line. If you're getting a decimal, you all know by now you rounded off to how much? 2 decimal places. So to find the gradient, I know the formula is not on this one, but it just had to turn back. To find gradient is y2 minus y1, always divided by x2 minus x1. The y's go on top and the x's go underneath. So I'm going to choose P first. So remember, x comes before y. When you're stating coordinates, you always put the x before y. Since we're choosing P first, everyone in P will have the subscript 1. So you call it x1 and y1. That means we have no choice but to choose Q second. So Q will also have an x coordinate and a y coordinate. X always comes before y. Because we're choosing Q second, we call it x2 and y2. So let's throw it into the formula here. It's y2 minus y1. y2, and this is y1. So it's 7 minus 20, and then x2 minus x1. 22 minus 13. 7 minus 20 is minus 13. 22 minus 13, I cannot do that in my head. 22 minus 13 is 9. So it's minus 13 divided by 9. If you leave it like that, it's not a problem. Or if you put it as a decimal, it's minus 1.444444, but I usually go to 2 decimal places. Okay? Right now, even if you're not 100% sure how to get the answer, like, but once you have a rough idea, because every time we bounce up a gradient question, I'm going to keep refreshing your memory on how to do it, right? So I'm just giving you a little jump start on it. Remember, well, just now I said lines could slope upwards or a line could slope how? Downwards. Here's what I want you all to do. I'm going to give you all a flat line, right? Like a flat line. Let me just show you what I mean, right? Erase that line, and I'm going to draw a flat line. Perfectly flat, right? I'm going to call this one M and the end of the line N, right? Once again, it doesn't matter what 2 letters I use. Let here be 17, 8, and let here be 24, 8. It's a flat line, right? I want you all to find the gradient of a flat line. I just write in the word flat line here because I want to show you a shortcut later on, right? Find the gradient of that line. A lot of people saw through my trick, but go ahead, work out the gradient calculation. So remember the gradient of a line. Well, let me write back the formula, right? It's always y2 minus y1 divided by x2 minus x1. I'm going to choose m before n, right? It must have an x and it must have a y. Because we're choosing m first, I'm going to call it x1 and y1. which means I have no choice but to choose n second. So it's going to be x21, y2. Let's throw it into the formula. y2 minus y1. You notice on top we end up with 8 minus 8. Underneath, we end up with 24 minus 17. Now, I'm not very too concerned about the underneath, but on top is 8 minus 8, which is 0. 24 minus 17 is 7. 0 divided by anything is 0, right? I want you all to make a note. A flat line always has a gradient of 0. Make a note. In the exam, when the examiner gives you a graph, if you see a flat line and he asks you what the gradient is, do not waste time doing any calculations for it because you will get 0. All right, so that's a little shortcut. So make that note. A flat line always has a gradient of 0. Look for your mistakes because a lot of people, for all those who got it wrong, let me know if you saw your mistake. Let's see what's next on the list here. Oh, by the way, the first letter of the day to make sure that we're paying attention is the letter K. Everyone write down K. That's our first letter of the day. K, as in kangaroo. All right, so we did this already, right? All right, so let's continue with our story with Mr. Jibby. As you all know, Jibby's life isn't going so well. So this is him attending the funeral for his family. Right now, unfortunately, Jibby is currently homeless because of all his hard life circumstances, right? But y'all can give the story a read. So the premise is that his sister usually appears to him as a ghost to give him advice and keep him company. Sister's name is Lily, and we'll see how this story goes. As you all know, AI isn't perfect, right? So Jibby he sees a wishing star and he makes a wish. If you all look at the top of the screen there, you'll see a shooting star. And the wishing star, a magic book appears. So you'll see what happens when he reads the book. Right, so we have some notes over here, right? So when we're doing distance, speed, and time, you're going to meet up a word called acceleration. Now, I know some of you all might not be familiar what acceleration is, like, but you all familiar with something called time. You all measure time all the time, right? Well, in this topic right now, there are many ways to measure time: seconds, hours, minutes, years, months. Usually for CXC, they only care about 2 types of units when it comes to time. Your time will either be what? In seconds, or the time will be what? In hours, right? S is for seconds. Hours supposed to be HR, right? I put H by mistake, but it's supposed to be HR. Distance, whenever we're measuring distance, something moves. It could be somebody running, it could be a car moving. The examiner will only use 2 types of units for the exam. It's going to be in meters or it's going to be in what? Kilometers. Speed is how fast something is moving. Speed will either be measured in something called meters per second or kilometers per hour. right? Trinidad cars, right? When you look at the speedometer, we measure speed in kilometers per hour in cars, in cars, sorry. But when somebody is running, like say Usain Bolt is running a race, they measure his speed in meters per second. That's the norm. Now, even if you don't know what acceleration is, I'll try my best to explain it as I go along. Acceleration is measured in either meters per second squared. And notice I have a little 2 above the S. Speed does not have the squared above the S. Or kilometers per hour squared. So it's very important that you know what you are measuring and you get the units correct in the question. So everyone, take down that table, right? And in case you don't know what acceleration is, the examiner for CXC Maths will never ask you to define acceleration. I just put what acceleration is here just in case you are curious, right? But just know you only need to know the units of acceleration. Take down the entire table, and we're going to start some heavy calculations. Right. So I think everybody knows how to convert basic things like meters to kilometers and whatnot. That was done in primary school, right? And how to convert time to seconds, from seconds to hours, or hours to seconds, or to minutes and whatnot, right? What we're not familiar with is this guy here, the speed, right? A lot of people don't know how to convert meters per second to kilometers per hour. Or if you have kilometers per hour and you need to convert it back to meters per second, a lot of people, that's not general knowledge, okay? So I have some a little table here. Let's say I give you kilometers per hour and I want you to convert it to meters per second. All you have to do is take the kilometers per hour and multiply it by 1,000 and then divide it by 3,600. And that will convert what? Kilometers per hour to meters per second. If you want to do the opposite, if I give you meters per second and I want you to convert it to kilometers per hour, all you have to do is the opposite. Take the meters per second that I gave you, you multiply it by 3,600 this time, and then divide it by 1,000. Okay? So take down that formula. That's a speed conversion from kilometers per hour to meters per second, or vice versa. Right. Now, there are two types of graphs that you're going to be given questions on. One is called the distance time graph, where the y-axis will be distance and the x-axis will be time. The other graph is something called your speed time graph, where they will measure speed on the y-axis and time once again on the x-axis. Okay? So the two graphs make a big difference, right? Let me say the examiner draws a graph like this for you, and it's a distance time graph, right? It's a distance time graph. The gradient, whenever they give you a distance time graph, the gradient of any line on the graph will give you the speed of the object. So in a distance time graph, gradient gives you speed. If you find the area underneath the graph, it tells you absolutely nothing of importance. It's a trick question, right? And of course, remember, a flat line has a gradient of what? 0. In a distance time graph, if you ever see a flat line that means on that flat line, the object is not moving. And that actually makes sense, right? Let's call here A, let's call here B, C, and D. Between B and C, do we all agree that the gradient is 0? Between B and C, because gradient gives you what? 0 of a flat line is 0. Now, if gradient represents speed, and I just told you the gradient of a flat line is 0, then that means the speed between B and C is 0. When something has a speed of 0, doesn't that mean it's not moving? So it's a little shortcut, right? Anytime you have a distance time graph, it has to be distance time graph. Anytime you see a flat portion, that means the object at that point is not moving. I want everyone to take down the top half for me, and then we'll discuss the opposite, the speed time graph. Opposite, right? The other type of graph is a speed time graph, okay? Now, in a case like this, the gradient will not give you speed. Instead, the gradient will give you the acceleration of the object. If you were to find the area underneath a speed time graph, like the area of the graph, it actually tells you something useful this time. Remember, in a distance time graph, the area underneath the graph tells you nothing of importance. But in a speed time graph, if you were to find the area, that would be equal to the distance moved by the object. Okay? Right? Great. So, in a let's clear this up, right? Because in a distance time graph, whenever you see a flat line, right? Whenever you see a flat line in a distance time graph, this means the object is not moving. However, in a speed time graph, if you see a flat line, that doesn't mean the object is not moving. That means the object is moving, but it's moving at a constant speed. The acceleration would be 0. Now let's zoom into that. Acceleration means to change your speed. Let's say you are running, and sometimes you run fast, and sometimes you run slow. So you run fast, and then you slow down. Anytime you change your speed, your acceleration changes. And acceleration causes a change in your speed. Is it when something is moving at a constant speed? In other words, it's not speeding up and it's not slowing down. For example, what's the speed limit on the highway? The speed limit on the highway is 100 kilometers per hour, right? If you are driving at exactly 100 kilometers per hour, it would look like a flat line on a speed time graph, because the speed not getting higher and the speed not getting what? Lower. The acceleration is 0, because an acceleration causes a change in speed. So if your acceleration is 0, that means your speed is not going what? Faster or slower. You're just stuck at one constant value for your speed. Okay? Take down the underneath one now. You don't have to take down all of this, right? Don't worry, I'm going to keep refreshing your memory, right? When we do the distance time graph, I'll say, hey, turn back to the notes on distance time graph. And you'll hear me say the same thing that's on this slide like 10 million times. For those who did this in physics, this will be a breeze, obviously. All right, so we got a little break here. So as you all know, he wished on a wishing star and this magical book appears, right? So this being a story, he looks into the book and something happens. The book pulls him into it. Right, so that's Jimmy being pulled into the storybook. And of course, let's see what happens to him. I didn't get time to do the voices and whatnot for it. But so Jimmy is thrown out of the book and he hears horses running and soldiers shouting in fear. So you all see the book at the top right-hand side of the screen, and that's Jimmy. He comes out on the other side of the book. It's in there. And he has a little armor suit on and everything. All right, so things seem to be looking goodish for Jimmy at this point. Let's move on. Oh, y'all want to take a guess? One of the horsemen is saying, it's coming, turn turn back to the castle. Anybody want to take a guess of what is chasing them and why they're fleeing in fear? I always like to hear the guesses. Someone says a titan. Not too sure what a titan is. I've heard the name. Cyclops, a dragon, a giant. Somebody said their mommy. All right. All right, let's move on. All right, so here we have our first graph, okay? You do not need graph paper, all right? All you have to do is draw X and a Y axis like this. Just draw. This is the Y axis, as we all know. Notice the Y axis is distance, and the X axis is measuring time. So this graph is a distance time graph. You don't need to put the values like 2, 4, 6, 8, 10, or whatnot. Just draw a Y and an X axis. In other words, do exactly this. Draw this using your ruler. Put distance on top here. Put time over here. Make sure I put seconds. Put meters here. And then draw this graph like this. That's all I'm asking you to do. And put A, B, and C. Draw that and let me know when you are finished. For those who want to put in the numbers, I know I can't stop you, but it won't be necessary. Let me know when you're ready, and we will do the first question. Yes. So the bird is asking, what is the speed between A and B? Now, this graph has two portions, right? A slanted part going upwards and a flat part, okay? So in a distance time graph, what tells us the speed? Go back in your notes, look at the distance time graph. What tells us the speed? Is it the area or is it the gradient? In a distance time graph, what tells us the speed? Right, and I'm going to write it in, right? In a distance time graph, and this is a distance time graph, it is the gradient that tells us that quantity. Great. So you notice I didn't directly give you the points. Now I want to know the speed between A and B. Well, that's what the bird said. You notice I didn't write all the points, but in the exam, you're going to have to read off the points off the graph. So A is going through the origin. So A is what? 0 on the X and 0 on the Y. And B, what's the coordinates of B? Isn't it 6 on the X and 8 on the Y? You notice you will have to read it off the graph and write it in on the diagram. Most examiners will not write in the 6 and the 8 for you and the 0 and the 0. So now that we have the coordinates of AB, A is the beginning of the line and B is the end of the line, do you all think you all can find the speed between A and B, better known as the gradient? Remember this formula? How you find the gradient of a line? Y2 minus Y1 divided by X2 minus X1. Find the speed between A and B and send the answers on the chat. And you notice there was no tricks in this question. The distance was measured in something acceptable. Distance is meters, meters is acceptable, and the time is in seconds. That is acceptable on the CXC syllabus. Right. Francis, check it back. That's not correct. Check. Let's work this out. So I'm going to choose A first, right? Because, A comes before B. If you choose B first, you're still going to get the same exact answer. It's like magic. So A has an X coordinate. Let me get a better color here. A has an X and a Y. Because I'm choosing A first, I'm calling it X1 and Y1. B comes second. So you have an X coordinate and a Y coordinate, right? So because I'm choosing B second, I'm calling it X2 and Y2. How much people have up to there correct at least? You had the X1s and Y, the names X1 and Y1 and whatnot correct. Great. So it's just to throw it into what? The formula now. And this is where I think a few people are making some mistakes here. Now, if you what I want you to do is physically writing X1 and Y1. I know what happening. Some people imagining X1 and Y1 and X2 and Y2 in their heads. That's really not a good idea. Plus, you're going to get marks for writing it in. So you might as well write it in. Y2 is how much? Look at it. I'm going to put the arrows here. Y2 is 8 and Y1 is 0. X2 is 6 and X1 is 0. If you don't believe me, look to the left of the diagram. So you're going to get 8 minus 0 and 6 minus 0. So you're going to end up with 8 divided by 6, which is 1.3333333, right? You can put 1 and 1/3. I'm not going to fight about the decimals or fractions. But remember, we are measuring speed. Look back in your table. There are two ways to measure speed: meters per second or kilometers per hour. Yeah, but don't take my word for it. Go back in your table and you will see that there are two ways to measure speed. Make sure you physically see it, right? I want you all to tell me which is the correct one to choose today. Should it be meters per second or kilometers per hour? A question like this only going to be worth about 2 marks or 3 marks. Very rare it will be worth 3 marks, more likely 2. Right. It's going to be meters per second, because if my distance is being measured in meters and my time is in seconds, any likely choice here is meters per second, not kilometers per hour. So your graph will kind of give you an idea of what your final answer units should be, right? Great. Right, so for those who got it wrong, so a few people said the answer was 48. I'm not too sure where you got 48 from, but at least let me know, right? Okay. Look at it here. X2 is over here. Look, I have it here. X2. X2 is at the top above the 6. X2 is here. Don't worry about the distance. Sorry, this is just an error here that something got printed there by mistake, right? Don't worry about the. Let's go. Right, so the bird has another question. If you notice, it's the same exact graph. What is the speed between B and C? How you find speed again in a distance time graph, and it's supposed to be gradient? So they're asking you to find the gradient again. But this time they're not talking about A and B. They're talking about between what? B and C. So quick. Do your calculations and get the gradient between B and C. It could be anything, right? Who knows, right? In this question, B and C is a flat line. Remember, the gradient of a flat line is 0, right? So remember, so that means the speed is automatically equal to 0 because the gradient represents the speed. So I will not even waste time. The only time I will waste time doing this is if the examiner just asks, right? If he just asks, what is the speed between B and C, right? Right? If you didn't, how I say, if he just phrased the question like that, between B and C, the answer is just zero. You have the option of what? Just stating it zero, right? Um, But if he says calculate or show that the calculate or show the value of the speed between A and B, if you phrase it like that, then you have to do all the working. Okay? Right? Uh, Let's see what's going on here. Right. Now, here's the thing. Here, here's another question. I don't want you all to mix up the terms speed and average speed. It's real different, okay? If I ask you to find the speed, right? If I ask you to find speed, I do not use the word average. And it's a distance time graph. We all know by now, by me saying it so much times. If you want to find the speed, you find the gradient of that particular point or that particular line on the graph that the examiner is talking about, right? But if he says average speed, I hope I spell average correct there. He wants you to take the total distance traveled by the object divided by the total time that he is referring to. Now, let me show you how to interpret this formula. So this bird comes up and says, hey, find the average speed. Now, based on how we phrase that question, we have to assume he's talking about the whole graph, right? Because he didn't say, what's the average speed of AB or BC? He just said, the average speed. So we have to use a little bit of common sense and say, all right, he's referring to the whole graph. So he's referring from A all the way to the end of the graph, C, right? According to the formula, to find average speed, we have to take the total distance. Anybody wants to tell me what's the total distance traveled by that object? In other words, where is the end of the graph? The end of the graph is C, right? You want to tell me how much meters he went when he reached point C? What was his distance at that particular point? When he reached the end of the graph, what was his distance moved? Remember, the y-axis is telling us the distance, right? It's not 12, guys. It's 8. Look at it. Let me use a different color here. Isn't the distance 8? Remember, the y-axis is telling us distance. The y-axis has been given a job. We hired him to tell us the distance. Okay? Everyone okay with that? For those who got it wrong, the total distance, in other words, at the end of the graph, when we reach point C, we ask ourselves, hey, what's our distance, man? And our distance is what? 8 meters, okay? How long did it take to move that 8 meters? Isn't that the x-axis job? Isn't the x-axis telling us the time? What's the total time at point C? In other words, you're taking all the values at point C. That's why a lot of people are telling me it's 12. It's what? I'm not seeing that 12, guys. It's what? Anybody want to take a shot there again? It's 10, right? The total time is 10. So at point C, the total distance moved was 8, and the total time taken was 8. So 8 divided by 10 is 0.8, and its speed, so it's meters per second. So average speed is just the total distance of the entire graph divided by the total time. It doesn't really focus on a specific portion of the graph. It's usually referred to a bigger portion of the graph. Most of the times, the whole graph is what they're referring to. Right? And this is just distance time graph. That's enough time. That. And that is what was chasing the horseman. So Jimmy starts to run. All right. So I think um the AI program I used did a really good job at doing the diagram. Only one thing, if you all look closely, right? Jimmy has 3 arms. I don't know what's going on with the AI. Every time he's running, it puts 3 arms. I don't know what's going on. And oh yeah, the dragon has 3 legs, and I'm realizing that too. What are you gonna do? I now saw that. All right, let's go. Right, so things aren't looking too good now. The fire also breeds the dragon also breeds fire. I know what's going on. All right, so we'll see what happens eventually. Look at this graph here, looking a little bit complicated, right? But you just need to draw the general shape of the graph, right? And then we will put in the values for P, Q, R, and S, okay? Notice this time, the distance is being measured in kilometers. Nothing wrong with that. That is acceptable in the exam. And the time is in hours, which is also acceptable in the exam. So everyone draw the graph for me and see if you can answer the parrot's question. I'm trying to trick you a little bit, but anyway, give it a try. Doesn't matter if you get it wrong. I really don't even care if you get it wrong. I just care if you try. That's all I care about. All right, let's see. So it's between P and Q, right? P is the origin. P is 0, 0. And if you look at Q, Q is how much on the X? 2. And how much on the Y? 5. Everybody with how much people at least have those values correct? You were able to extract the P and Q values from the graph. Great. So remember, in a distance time graph, the speed is equal to what? The gradient. So we know the formula for gradient, y2 minus y1 divided by x2 minus x1. So I'm going to choose P first, call it x1 and y1, right? Remember, the 2 must come before the 5. I think we've been through this already. The x must come first and the y must come second. 2, 5 is 100% different to 5, 2. You have to read off the x coordinate first. So it's x2 and y2. We should be good there, right? P is x1 and y1, and Q is what? x2 and y2. Let's throw it into the formula. Y2 is how much? Well, I have it here. Y2 is 5, y1 is 0. So it's 5 minus 0, and x2 is 2, and x1 is 0. So it's 2 minus 0. So we're going to end up with 5 divided by 2, which is 2.5 hour. Remember, there are 2 ways to measure speed: meters per second or kilometers per hour. But if my graph has kilometers and hours, would my speed naturally come out in kilometers per hour? How much of you all at least had that in your calculations? It's not the end of the question. It's not the end of the question. You know why that's not at the end of the question? The examiner wants the speed in meters per second. We just got the speed in kilometers per hour. Remember a few slides down the road, I told you there is a way to convert kilometers per hour to meters per second. Turn back in your notes. How do you convert kilometers per hour to meters per second? Remember, look at it properly. It's easy to mix up. You multiply it by 1,000 and then divide by 3,600. So here's what you need to do. That 2.5, which is your kilometers per hour, multiply it by 1,000 and then divide it by 3,600. And your answer will come out in meters per second. So get it correct now, right? At least send the final answer for me. I'm getting 0.69 meters per second. Let's try the next part of the question. All right. Now read this question properly, right? Let's give it a read. This one is more of a common sense question. There isn't too much calculation for it. Which axis is telling us distance? The y-axis, right? So we can read things off the y-axis. If I start at P and I go to Q, right? Remember, P is what? 0 meters. You're reading off the values, right? Between P and Q, how much kilometers did I move? I started at P and then I went to what? Q. Don't overthink it. And it's 5 kilometers. And yeah, well, I got converted to meters after, but that is working with the kilometers, right? And it's straight off. Now they want to know what's the distance between R and S. Now look at this. If I'm at R, what's the distance at R? 5. And at S, I end up at 15. So for RS, if I start at 5 and I run to 15, what distance did I move? I started at 5 and I moved to 15. And that's just 10 kilometers. Because, in other words, this distance here is 10 kilometers from 5 to 15. They are asking you what's the difference between two of them. So that, you know what difference mean, right? To minus. So they're asking you to minus RS and PQ. That is all they're asking you to do. So 10 minus 5 is 5 kilometers. That is all. And then they want you to convert it to meters. How much kilometers in a meter? 1,000. So the answer is 5,000 meters. So you had to do this question in 2 parts. Find the distance moved from P to Q, and then reason out the distance from R and S, and then the parrot tell you to minus it. But he didn't say minus it, but difference mean, we know from primary school, the difference of 2 things is to minus it. So when we minus 10 and 5, we get 5 kilometers. So people were overthinking this one. This one had nothing to do with speed or gradient or nothing like that, right? Francis, you understand it, right? They didn't ask you to calculate anything with gradient, right? They did not ask you to calculate speed in any way, right? So not all the questions that's going to come has to do with gradient, not all the questions. Oh, we have a little breezer here. So apparently they escaped the dragon because the dragon was getting tired, right? All right, so that's Lord Ritter, the guy with the red beard. You might want to remember his name, right? Oh, by the way, the guy in the cloak, his name is Gum Gum. I don't know where I got these names from, right? So apparently Gum Gum was going to try to murder Lord Ritter, but Jibby jumped in to save the day, and Jibby knocks him off the cliff there. Yep, but Gum Gum is a wizard, so he turns into a crow, and you know. All right, so let's continue there. We'll see what happens to Lord Ritter and Gum Gum there. Find the average. Oh, this is a good one. Look at this. They said average speed. Remember, I told you all, speed and average speed is two different things. Go back in your notes. Look for the formula for average speed. Remember, in this question, the distance is in kilometers and the time is in hours. So that means our speed will naturally come out in what? Kilometers per hour. We will need to afterwards convert it to meters per second. So what's the total distance? At the end of the graph is at S. What was the total distance at S? 15. And how much hours did it take? 5. So it's 15 divided by 5 is 3 kilometers per hour. But we don't want the answer in kilometers per hour. We want it in meters per second. So how do you convert kilometers per hour to meters per second again? Remember, you multiply by 1,000 and then divide it by 3,600. The examiner will not remind you of that formula. You need to remember that. I'm getting this 0.83 meters per second. That's my final answer. And you have to make sure and put what meters per second.